Hello everyone, today we're looking at Leetcode problem number 1526, minimum number of increments on subarray to form a target array. So in this problem, we are given an integer array which is called as target and an integer array which is called initial. So initial is not given to us because it's just an array of same size as target but has only zeros. So what we have to do is we have to perform few operations and see how many number of operations we need to get from initial to target. Now in one operation we can choose any subarray and we have to increment the value by 1. Now since we can return uh, different subarrays, and for that subarray that we are selecting, we're incrementing the value of each element by 1. We can be doing this in groups like this. We have to identify the number of operations required to form target from initial. So let's look at one example to understand what this is saying. Let's say I have 1, 2, 3, 2, 1. This is my target and I have my initial which is of the same size. So this is 5, 0, 0, 0, 0, 0. And now I need to take a subarray and increment. So now uh, all of them are greater than or equal to 1. So in one operation, I can increment all of them to 1. Now, if I look at this subarray, all of them are greater than or equal to 2. So in this operation, I will take this subarray and increment by 1. So this becomes 2, 2, 2, 1. And then I only need to focus on this element. So in the third operation, I get 1, 2, 3, 2, 1. And we have attained our target. Let us look at another example, which is 3, 1, 1, 2. And my initial in the beginning is just zeros. So all of them are greater than or equal to 1. So in one operation, I make them all 1. And now what happens is that I have a smaller value in the middle. So I cannot take second operation and update all of them to 2. This is like the break point if you want to call it. So then what I can do is either choose this side or this side and then increment. Let's say we choose this side. So we've already gotten the value of 1. So in 2 more operations, so 1 plus 2 more operations, I can get this to 3 and then 1 1 stays and then this. Now this position already has a value 1. I need to take it to 2. So 1 plus 2 plus 1 in one operation, I can take it to 2. And so my total number of operations required is 4. Now, the breakpoint that happens here is the most important thing in terms of thinking about it. Um, Another thing which is very important is the constraints. So, if you look at the constraints, the length can max go up to 10 to the power 5, and the values can also max go up to 10 to the power 5. So I cannot do anything with regards to the value, thinking that okay, if this like if I have certain value here, that many times I increment, or even iterating through the array multiple times, those are not possible. So we'll have to think about something that we do in either order of n or order of n log n times. So instead of now trying to solve this problem as trying to figure out the different subarrays, can we treat this problem as a series of increasing and decreasing values? And so what that means is that every time we are increasing, we are basically already, let's say if I'm at this value, let's say this was 2, 3, 4. Okay, I need 2 operations to get to this state. But when I'm at 3, I need only a delta operation which is equal to 1. So from 2 to 3, I need only 1 operation. And so likewise, we can keep adding from 3 to 4 another 1 operation. And so 2 plus 1 plus 1 to come up till here. But if I am decreasing, so let's say if I'm at this value. Now if let's say this happened to be 5. Okay. If I'm at 5, then that means I have already, I would have already counted numbers lesser than 5. So let's say if I had 3, 2, 1, then if I have achieved 3, that means I have already iterated 3 times, which means first time I had 1, the second time I had 2, and the third time I had 3. So that means I have already covered these in my iterations, and hence I don't need any extra iteration. So when I'm going down the hill, I need 0 extra iteration. So maybe all we need to do is find the breakpoints and then count all the extra operations that I need from the previous step. And that's the core logic of this problem. The code is quite simple if we get the intuition of solving this in this format of ascending, descending, and creating the breakpoints. So let's write the code. So let's see, my total operations is equal to the first value, which was, we are going to assume that we are starting at this point. Okay, there is a possibility that from that point we increase or from that point we decrease, doesn't matter, but we have to start at that point. So this happens. Okay, and now what we do is, let's say we are already at this point. From here there is 2 possibilities. We could either be going here or we could be going here. If we are going here, I don't need to count anything because that count is already counted in this one. But if you're going here, I'll look at this delta value that is happening between this. I actually compute this and that, and I keep summing on that. So let's do that for I in range from 1 to len of targets. Sorry, and then what I say is, if target of I happens to be greater than target of I minus 1, then I will increment my total operations by the delta, which is target of I minus target of I minus 1. And finally, I return total operations. Now the time complexity is going to be order of n because we are not doing anything other than just traversal, and the space complexity is going to be order of 1 because we're not making any extra storage. That's about it for this problem. I'll see you with the next one tomorrow. Thank you. Bye bye.